Hey guys, in my spare time, I've been taking this course on database engineering from Carnegie Mellon University, and I've also been learning a bit of C++ on the side just for fun. This course is really good, but it doesn't have many, or it doesn't have any practical lab exercises. So I've been making my own lab exercises based on the content that I've been learning. So one of the lectures was a data compression lecture, and it went into some detail about dictionary compression, which I had never heard about before. So I decided I'm going to implement that today by using dictionary compression to compress a large JSON file. So what is dictionary compression? In this JSON file, you can see there are multiple repeated strings. We can create a dictionary for these strings by placing them in a data structure like a hash map. Then we can assign each string a unique code. This code could be something simple like a number or some hash value. Then we can replace all instances of the strings with their corresponding code. And now we've nicely reduced the amount of characters in our file. With enough repeated strings, this can potentially reduce the file size by a lot. Finally, when we want to decompress the file, we can scan the file and replace each code with its corresponding string and get back the original file. There's a couple of issues with this approach. Let's say, for instance, we convert this Shakespeare string into a unique code. This works fine because the length of the code is less than the length of the string. So we're all good. Now, if we try to do the same thing with this smaller ID string, we're going to generate a code that is longer than our initial string. So it's better to not convert smaller strings if you can't generate a code that is smaller than them. Another issue is the dictionary has to be stored inside the file for later decompression, meaning you must always store at minimum one instance of each string that you're converting. So it'll only make sense to convert repeated strings. Even if you have some massive string that's all on its own, and you know you can replace that with a tiny little hash code, it won't make a difference at all to the file size because you still have to store that massive string inside the dictionary anyway. This is the JSON file that I'll be compressing. It's a great candidate because it has heaps of repeated strings. Its current file size is around 26 megabytes, so we're going to try and compress that. I found the file on GitHub. If you want to check it out for yourself, I'll put a link to it in the description of the video. The project structure looks like this at a higher level. First, we have our JSON file that we want to compress. Then I have a function that scans the JSON file and creates a big list of each individual word or token. Then that list gets passed into our main library, this dictionary compression C++ file. This is where the actual compression stuff happens. And that file outputs a hash map, which represents our dictionary. So it'll contain the unique tokens and their corresponding hashes or codes. Then finally, the dictionary is used to create our output file, and the dictionary is then stored in the output file. I won't be focusing on the file input and output parts of this project because I don't think it's that interesting, but if you want to see how I did it, I'll leave a GitHub link down below. So my main focus will be on actually building the dictionary, which is done in this main library here. Basic strategy for converting a list of tokens into a dictionary is this. First, start with the list of tokens. Then iterate through the tokens and count the amount of times each token appears. If you use a hash map, you can do this in one pass or linear time and space complexity. From here, we can decide whether it's worth it to encode each token. In this example, it's not worth it to encode the Python string because there's only one instance of it in the file. So we gain nothing from encoding it. The other two strings occur multiple times, so we want to keep them for the next step. Finally, we can build the dictionary using a hash map. We have to figure out a way or a method to encode our tokens. My first idea was to run the token through a hash function and then just use the hash number for our code. This method had some pitfalls to it, which I'll demonstrate later. starting off with mapping the token frequencies. We're just going to iterate through the list of tokens, then keep a hash map as the output, add each token to the hash map. If it already exists in the hash map, we just increment the count. If not, we'll set the count to 1. Now to actually build our dictionary, like I said before, my first thought was using a hash function to generate our codes for each token. So I'm going to demonstrate that now. So to build our dictionary, we're going to need to keep a hash map as our output. And if we find a token that's worth encoding, we'll insert it into our hash map along with its code. The next step is our code has to be a certain length in order to guarantee that we can have enough unique codes to handle all the possible tokens that need encoding. In this case, I've elected to use a 7-digit hash number to represent our codes. So it wouldn't really make sense to encode any tokens that are less than or equal to 7 characters in length. Next, we go through every token in the list to find which ones are worth encoding. The condition is there must be more than one instance of the token in the file, and it has to be longer than the length of our hash code. Next, we apply the hash to the token and store both as a pair in our dictionary. So now that we have our dictionary, we can send that to our file input output library, which will write that as an output file. And ideally, we will see a file size reduction. So we're going to compile that. Then run the program. Then we're going to check the output file size. You can see this is our input file sitting at 26 megabytes, and our output file is sitting at 19.8 megabytes. So that's a success. We've had a nice file size reduction, and let's just double check the output file. So you can see at the top, we've got the JSON, and here's an example of where we've compressed a repeating string. We've just shoved our hash code in there. And down the bottom of the file, you can see the dictionary, which has been appended to the file. So here's an example of a repeating string, and next to it is its hash code. So awesome, we've managed to replace a bunch of repeated strings with these 7-digit hash codes. But the question is, can we do better? Can we do better than 7 digits for each repeating string? Well, one simple thing that we can do is to shorten the length of our hash code. What this does is increases the amount of strings that we can hash. However, it also reduces the number of possible hash codes that we can use, which increases the chance of a hash collision. So there is a trade-off to this. So I'm going to reduce the min token length by 1, and we're going to see, hopefully, this will give us a even larger file size reduction. Compile the program, run it, and let's have a look. Yep, success. So you can see we've reduced the file size even more by about 0.7 megabytes. But can we do even better than this? Back in our dictionary building function, instead of using a 6 or 7 digit hash number, what we can do is simply use some special character as a delimiter, followed by a very simple count from 1 up to however many strings we need to hash. So it would look like this: some special character followed by a count, starting at 1, then 2, then 3, etc., up until whatever big number we end up with. What this means is we will have a variable length code. So we just need to check every time that the string is larger than our current count. So let's get rid of our old logic and add the count in. Okay, so now all I'm doing is using this special character. I just used a random ASCII record separator. I'm not 100% sure what that does, but it'll do for our purposes. And then instead of checking against some minimum value, we just check to make sure that the string we want to hash is larger than the length of the count. So in doing this, we should be able to massively increase the amount of tokens that we can hash and theoretically get an even bigger file size reduction. So let's see how it goes. So we're going to compile that program, run it, and let's check the file sizes. Damn, so that was a failure. It looks like we haven't done as well as last time. Last time we had 19.14 megabytes. Now we have 19.17 megabytes. I did this live and I really thought that it would work out better, but it didn't. So let's have a look at the output file to see why this didn't work. At the top of the page, you can see a bunch of strings got hashed with our delimiter and our count value. However, it just so happens that the amount of strings that we wanted to hash ended up being roughly 6 digits worth anyway. So one solution would be we could take away the delimiter character. However, if we decompress that, it's going to start becoming difficult to distinguish between our hash codes and legitimate JSON data. One idea that's just come to me is we could reduce this code size a little bit more by using hexadecimal numbers instead of integers. So I'm going to figure out how to convert my count number into a hexadecimal number. Okay, so now, ideally, when we run this program in the output file, we should see all of our codes being represented with hexadecimal numbers, and that should shrink it by 1 character, ideally giving us a boost in our compression ratio. All right, fingers crossed. Yes, success. So we squeezed another half a megabyte out of that. So from 26 megabytes down to 18.5 megabytes is a compression ratio of 1.4. I'll take that. I'm happy with that. I have a few more ideas for decreasing the file size even more, but I'm not going to go through them in this video. I will keep working away at them in the repository. I'll link that down below. So if you're interested, give that a follow. Yeah, I'm just looking at the output file here. You can see there's a bunch of places where we ended up hashing these strings. Yeah, it's pretty cool. I'm not going to go through decompression in this video either because it's basically just file input output stuff. It'll be fairly simple. But yeah, keep an eye on the GitHub repository. And that's about it for this video on dictionary compression. Keep an eye out for more videos, and thanks for watching.